A variable is any trait or any feature for the thing we are trying to measure or study. And the trait or the feature can change over time. So the values for that trait or that feature varies over time. And a variable has to be at least two categories: sex, race, military ranks, education level, income groups, age groups, and whatnot. Two categories. And those categories are also mutually exclusive. You can be either male or female. You cannot be both. Biologically, you can only identify yourself as one of the racial ethnic groups, technically. And a person can only have one military rank. And you only have one highest level of education. You can only belong to one income group. Anything with only one category is not a variable, it's a constant, like the pi in mathematics. It only has one value, 3.14 ... or the natural logarithm. It only takes one value. And a variable can take many forms. It can be continuous. The value continues on, like age, income, weight, BMI, height, distance travel, length of stay at the hospital, and whatnot. Its value is continuing from the lowest to the highest. A variable can also be about somebody's opinion about certain issues. Strongly agree, disagree, neutral, agree, strongly agree, and whatnot. Opinions often takes the form of a Likert score, where you give a number 1 to 7, where 1 is the lowest and 7 is the highest. That's a variable too, because it has multiple values. And the value can vary from person to person.
Okay, this is what we mean by operationalizing variables. And one major rule when we operationalize variables is that the attributes we specify for a given variable must be exhaustive and mutually exclusive. That is, the categories cannot overlap. Sex can be categorized into males and females, and race or ethnicity can be classified into white, non-Hispanic, black, non-Hispanic, Hispanic Asians, Native Americans, and other. And once again, there are no overlapping categories. This is what we mean by mutually exclusive. And again, marital status can be classified as single, cohabiting, married, or living with a partner, married and living separately, separated, divorced, and widow. And once again, you can be in only one category in a particular time point. The same thing can be said for age. It can be classified into, let's say, 18 to 30, 31 to 45, 45 to 59, and 60 and above. And once again, as is the case with marital status, you can only be in one age category in one particular time point. And this is what we mean by operationalization of variables. It involves specifying how the variable should be defined and how its attributes should be measured for a given research project. And we saw many examples in the previous slides. And how a given variable is operationalized determines how the values of that variables is distributed or spread out. And I mentioned before, there are two main categories of data distribution. There is either a symmetric distribution or a skewed distribution. And for skewed distribution, the data can either skew to the left or to the right. And the normal distribution, which has the shape of a bell curve, is a special kind of the symmetric distribution. Okay, if you don't know what's a normal distribution, you can check out my video on YouTube, or you can do a search on YouTube and you'll find many relevant videos on normal distribution. And when we talk about symmetric distribution, we will notice that the mean, the median are the highest point, or the categories with the highest frequency for the variable or the data. And as you can see from this diagram, the mean, the median, or the mode, they will be somewhere in the middle of that distribution, or they stay close to the middle of that distribution if the data is symmetrically distributed. And this is a simple way to tell whether the data is skewed to the left or to the right. We look at the direction of the tail. If the data is skewed to the right, the tail goes all the way to the right, and in this case, the mean will be greater than the median, and the value for skewness will be a positive value. And for variable or data that is skewed to the left, the mean will be smaller than the median, and the tail will be heading towards the left direction.